everyone. We're going to continue from our video on equilibrium and just learn to calculate the equilibrium constant. So in the previous video, just for a reminder, equilibrium constant is a way that we can measure whether an equilibrium reaction is product or reactant favored. Okay, and equilibrium means we have this double arrow where the rate of the forward reaction equals the rate of the reverse reaction. Okay, and so now we're given actual values. Okay, these brackets mean concentration, and this molarity, M stands for molarity, which is moles per liter. Okay, this is the concentration of these reactants and the product here. Okay, and so we're going to put these numbers into our equation for K. K equals product concentrations over reactant concentrations, and then we have to raise these to the power of the coefficient. So we just have a 1 and 1 here and a 2 there. So we have to raise these to the power of their coefficients. Okay, so there it is. So if we just write the expression out first, K is equal to product, which is AB, just general form. This is not an actual, of course, reaction. We'll do a practice with actual compounds in there. Okay, raised to the second power divided by concentration of reactants. A to the first power, B squared to the second power, or excuse me, to the first power also. So we have ones and ones there. Okay, now we put the concentrations that we were given in the problem into here. So if you look back, we had 0.25 of A and B and 0.50 of the product. So we put 0.50 and then divide that by 0.25 times 0.25. Okay. If in your calculator you have to do this separately, some of you, if you have a scientific calculator, you can plug everything in at once or whatever, but if you're getting the wrong answers, that's why it's a good thing you're watching the videos and doing practice, then it's something with your calculator if you're putting it in correctly. So, and remember, it's 0.5 to the second power, not 0.5 times 2. Okay, and so you get 0.25, and I'm going to check this real quick and make sure. Okay, and then you divide it by 0.25 times 0.25. Okay, and then we should get 4. Okay, and we get 4.0 because we need 2 sig figs, because we had 2 sig figs in our concentration values. So K is equal to 4. Okay. Usually the units are omitted here, so most times in chemistry we have a unit, but here it's omitted because the answer is usually in moles per liter or molarity, and this is just usually omitted, kind of like it cancels or whatever, but this is concentration that we're plugging in molarity. Okay, and then if we think about this further, so K is greater than 4. So just to kind of remind you of what we learned last video, if K is greater than 1, then the reaction is product favored. Okay, meaning it lies to the right. Okay, and so we learned this. If we look back real quickly at our table, K is greater than 1, favor the products, and lies to the right. And then if it's less than 1, it favors the left, the reactants. Okay, we're going to look at a chemical reaction here for practice and plug into K. So I have products is NO to the second power. I have nitrogen gas to the first, I don't have to write that, and oxygen to the first. So I got my 2 here, and because these are ones, they're just a 1 there, and you can omit those if you would like. Okay, so now I need to plug in my actual concentration. So NO is 0.00956. That's molarity. Okay. N2 is 0.520. And O2, oxygen, 0.0662. Okay, and I almost forgot there my 2. Okay, so this number to the second power divided by 0.520 times 0.0662 gives us, this is our answer. Okay, so K here is less than 1. Therefore, if K is less than 1, this means that this reaction would be reactant favored and lies to the left. All right, thank you for watching.